They said it couldn't be done. vim9script's not a real language. You can't just take one language and make it in another language. You can't just transpile this into something NeoVim can run. They're wrong. They're all wrong. I'm gonna tell you about it today. My project, written in Rust by the way, has finally transpiled vim9script code that lives in upstream Vim, and that transpiled code that is now Lua has landed inside of NeoVim core, and you can use it yourself today. Now you might be thinking, TJ, was I so preoccupied with whether I could that I didn't stop to think whether I should? So let's answer that question first, and then we'll talk about some of the interesting technical details about this project, and I'll show you some examples. Let's get to it. The reason that we're making this project is because vim9script has been merged into Vim core. In the past, you may be familiar that vim9script was approximately the same between Vim and NeoVim, and that NeoVim kept a lot of the same code from Vim, although a lot of the core engine was rewritten for different aspects of parsing and other future projects that never ended up panning out. But regardless of that, Bram has made a new version of vim9script, which I think is unarguably better than the old version of vim9script. It contains a lot of great new features, it has incredible speed boost compared to vim9script, and as well, I would say, removes several, if not many, warts from the original vim9script language. So you're probably asking, well, why doesn't NeoVim just take that and put it into NeoVim, and then we can have the same? There's a couple problems. The first is that there's a high maintenance cost for us to keep this code. As I mentioned previously, we don't have exactly the same vim9script implementation anymore that Vim does, although we have a lot of the same functional outputs. This would make us porting patches from Vim to NeoVim more difficult because we'd have to examine the implications throughout NeoVim's codebase and explore some areas that are completely separate that NeoVim just does not have that Vim does. So this adds a really high maintenance burden to NeoVim maintainers. However, not only is it difficult in patching NeoVim, there's also a difficulty in ongoing maintenance. Here we search for all the places where there's code handling special cases, worrying about whether the current execution context, right, whatever is executing currently in vim9script, is in vim9script or not in vim9script. There's over 500 results currently inside of Vim right now today. This means as you're reading code top to bottom, you have to keep additional extra state in your mind if you're a contributor to NeoVim to know about the implications of whether this should do something different in vim9script versus vim9script. That just makes things more difficult on an ongoing basis, even for making brand new features in NeoVim. And the last reason is because NeoVim has really bought into Lua. We believe Lua is the future of scripting for NeoVim, and that while vim9script support will probably stay forever, I don't see any reason that we would delete the code there, at least not today. That doesn't mean that that's our first go-to recommendation for people to configure and script NeoVim today. And we prefer Lua, and we're adding many different features that are available only in Lua via different interfaces, new functions, and new modules, like the LSP. While you can call those from vim9script, they're not designed to work primarily for vim9script or in the style of vim9script, but instead to be an idiomatic, well-packaged, simple, and as small an interface as we can possibly make for these features. That means supporting vim9script and Lua at the same time really puts us in a bit of a pickle, because that would basically be pushing people in two completely separate directions for the future of NeoVim. So that being said, at this time, we don't think vim9script will ever get merged into NeoVim core. But that leaves us with a dilemma. The dilemma is that there are a bunch of very great syntax, runtime, plugin files that are all maintained in upstream Vim. And in fact, in the past, Vim and NeoVim have had quite a good and symbiotic relationship on these runtime files. If Vim merges new changes in, NeoVim will take those via patches. If someone finds a bug while using NeoVim, we suggest that they submit their patch upstream to Vim so that NeoVim and Vim can have the exact same behavior for many different types of files. This greatly reduces burden and confusion between the two communities and allows us to share a lot of great work and keep the Vim and NeoVim community strong together. But when those files are written in vim9script, we're no longer able to just directly pull those files in to NeoVim. We need some alternate solution. And as I've just mentioned, it did not seem that bringing vim9script into NeoVim provided the necessary benefits to justify that cost. So are we left hopeless? Are we left just without any chance of these two communities working together? Or can one boy in his basement really make a difference? It turns out, yes, he can make a difference. We've gotten the very first vim9script file, the very file that I was just showing you, completely converted into Lua that can run inside of NeoVim while still maintaining the exact same vim-script idioms and availability through APIs that you would expect if this file were still written in vim-script today. I'm super excited that this PR was merged and accepted, and you'll probably see a few more in the upcoming weeks where we slowly port some of these over and then develop a system that we can use to manage these throughout NeoVim core. So how did we do it? This project, vim9JIT, which is not actually a JIT, but it's a combination of turning vim9 into Lua, which for NeoVim will be interpreted and just-in-time compiled by LuaJIT and then being able to be executed. This project, as I mentioned, was written in Rust,
by the way,
and lives outside of NeoVim core. This project does not need to be shipped with NeoVim. Nothing about the project needs to be upstreamed or maintained by NeoVim core. Instead, files can be generated just like they would be through any other external build tool and then included inside of NeoVim's core libraries and shipped to you as just plain old Lua files. What I'd like to do now is show you exactly how this project works, where I got the inspiration, and then at the end show you some of the future work that we might do and mention some other things that are going on. Let's hop right into the code. But before we do that, if you want a real technical deep dive into how we made this, you should just buy this book from my friend Thorsten Ball. This isn't an ad, it's just an awesome book that I used to help me figure out how to write something that's this in-between mix of an interpreter and a compiler for this project. But you can learn a lot from this book, and it's really great, super fun, and Thorsten's a great guy. He's an author, by the way. So let's show you what it looks like for our code. In the Vim9 project, we basically have three primary modules. The first module is a parser, or a lexer, if you'd like. This lexer takes in some text and just turns it into tokens that are easier for us to work with for the rest of the time. Vim9script has some interesting tokens and some tokens that act somewhat differently depending on the context of where they are, but generally speaking, a lexer doesn't care very much about how that works. It just wants to turn them into things that later your parser will work with. Without getting into too much detail, since we only have so much time in this video, effectively what it does is it iterates over character by character, and as it encounters a new character, it's going to decide what it needs to do. Equal signs have a variety of different operators that they could be. So an equal could be, if it's equals equals pound, that means equal to. If it's equals equals question mark, that's equal to, but case insensitive. Equals equals with some other token just means that it's going to be equal to as well. You can see really the beauty, the elegance, the absolute majesty of Rust's pattern matching, making it very clear exactly what we're trying to do. And I'll note as well, a beautiful implicit return. Sorry, Prime. We do this for each of the different kind of characters. Some are more complicated than other, and some are quite simple. Some, like a left parenthesis, always just gets turned into a left parenthesis. One thing that I really like about how we're doing this is we're using a thing called snapshot, or some people might call it golden testing. I want to give you a brief overview of that because I think it's really exciting. What you see here is an example vim9script file. It's very simple here so far. It has something like passing a number or passing some comparison or passing some special expandable type that we don't have to talk about, or different kinds of ways of displaying numbers. Now, what you might generally do if you were writing tests by hand would be you would write out each of these cases, write something where you try and expect this, and then assert something about the results. What we're doing instead is we're using, like I mentioned, this idea of snapshot tests. So if we look at my lexer.snap file here, you'll see that we see the same text inside of this file. We see vim9script, or we see var a equals 5, we see var b equals a less than 5, etc. But what's interesting, this is generated based on the list of tokens that we've explored and found. And what we see is that the ranges are all underlined or under-careted, I don't know what you would call it, under-careted with what the type of the token is. So you'll see that we see var here, which is an identifier with the text var. We have a here, which is an identifier with the text a. And then we see an equal sign. That equal sign is a new type. So it's not an identifier, it's an equal sign. This allows us in the parser stage, part 2, to more easily work with the text instead of always just working with strings. We're sort of enriching the data model as we move through this pipeline. You can see as well that we have things like less than here, but you'll notice down here when we have this less than sign here, it actually becomes angle left, an identifier, because this is a special type of character because there's no space. Don't ask me. It's vim9script rules. Okay, I'm just the guy implementing the transpiler. I didn't make the language. But regardless, this makes it very easy to add new test cases. If we wanted to test something var e equals 7 plus 5, we'd save this file. We can go to our tests. We can run our tests for the workspace. And as it runs all the tests, it's going to say, hey, this snapshot no longer matches. Look at this newly generated thing. And I can examine this output and I can say, yep, that looks good. It's an equals. Yep, that's definitely a plus. And then an integer, that's a 5. Okay, that all looks good. Then I can do cargo insta review, which is a crate that can be used to do these kinds of instant snapshots. And I can just click accept. We've now accepted that and added a new snapshot. We run the new tests, everything passes. And to commit these changes, you would just examine the diff, make sure it looks good. You could commit this and then push it. And then what's really great is this completely shows exactly what was changed inside of your PR. So if you added a new type or fixed some bug or wanted to leave some regression test, it's very, very clear exactly what was changed. We actually use this style throughout the rest of the repo. We won't go into as much detail for the last 2 out of the 3 sections, but I really wanted to show you this and show you how powerful this can be, and it's really exciting. If you want to see more about snapshot testing, let me know, and I can maybe make a separate video about that. The second stage of the pipeline is called the parser. The parser takes these Lext tokens, or a tokenizer, whatever you want to call it, and turns it into a AST, abstract syntax tree. We use this to enrich the data model even further so that it's not just string of tokens, but now it's a list of statements or expressions. Now, the kind of weird thing about this one is that instead of having statements or expressions, we have X commands. That's the high level thing inside of vim9script. And so you'll see what we have are things like, we have a def command. That's how you define a function. A def contains some metadata about where the def starts. It has a name and has args. It has an optional return type. It has an end of line that must be here. It has a body, and then it has an end def, and then the end of EOL. And you can see that a body is actually a list of other X commands. So this is kind of like, in a sense, a recursive data structure, sort of. And so we use these to then be able to parse those tokens into this AST. Some snapshots for this look like, we take something like this that starts with a vim9script command. You can see that vim9script command right here. It has an empty line, so that's just a no op. We have a comment, that's this multiple expressions. And now we have an if command. This whole if command gets grouped inside of here. And then we have an if token. There's some condition. This is an infix. We don't have time to go through that, but just basically means that there's something on the left and something on the right and an operator. And you can see that as we go, the whole idea of what's happening in the code is you're reading it. For example, you can see clearly, yes, the left side of this really is a call to something that says pum visible with no arguments, right? This is pum visible, no arguments. We build up this entire structure that now has semantic information about what the code is trying to do. And then we get to that last, final, beautiful step of turning this tree into Lua code that can run inside of NeoVim. Let's take a quick peek. For that same if command, we have something now where we implement a generate trait for that struct. We don't have time to talk about what implementing traits is. If you're interested in that, go like our video with me and Bash Bunny about Bash to Basics and Rust, and then we'll make one. But regardless, we then generate some information here about what this if command does using the struct for an if command, which contains condition, body, else ifs, etc. And then we literally generate Lua that's going to do the same thing. Right? So if we have an if command, we have some condition. Inside of here, we have a body. There might be some else ifs. And then at the end, we have some else result. And then it's the end of this if condition. We can see exactly what that looks like. And there's a special little treat that goes with it as well. What gets really excited about this last section is that we can take these tests, which are in the style of the Vim runtime tests, and we can generate corresponding Lua tests that can actually be executed by NeoVim inside of our test suite. What do I mean? I mean, we have this vim9 script. We define a test, we define a cool new function, and then we assert that when we call these things in, we get 5, and if we put in 10, instead we get 10. This basically tests default values. So what does that look like for us? Here's the test that we generated using Plenary's style of busted testing, and we generate this cool new local func, just like you'd expect. We then assert equal that myCoolFunc equals 5 and myCoolFunc 10 is 10, and then we assert that there are no errors. This will then run in an embedded NeoVim instance, which is a full end-to-end integration test. We take this vim9 script code, we generate the corresponding Lua. That Lua is then executed by NeoVim, and we assert that the runtime behavior works. This gives really crazy fast iteration speed because I simply have to write up a test in vim9 script, and I can test the exact runtime of how that works inside of NeoVim as we go. This was a really key piece in being able to be confident that what we're doing both stays working and is safe and stable enough to get merged into NeoVim core. So using all of that, we were able to take this file, which is inside of Vim core right now. It's a completion script for C that uses C tags to provide surprisingly good completion inside of Vim without any other tool. And we could take this, which actually contains several interesting language features. It declares variables at the top level. It declares new exported functions. It calls different functions. It has subtraction. It has regex matching. It has string concatenation. It has method usage. It has slices. It even has methods on different lines that are passing inline lambda functions that compare values inside of whatever's getting past this previous list, that are getting filtered, that are getting extended, that eventually get put back into one list that get returned to you as a list of completions. This file is actually surprisingly complex, but the corresponding Lua code actually looks surprisingly good and very, very similar to what we see here. And I'll show you what's happening even for just this one little spot right here. So what do we end up with compared to that original tags? What we see here is that each of these tags methods, effectively what this does is it takes tags and it places it in this first spot, in the first argument. Then when you chain this again, you would put the result of that inside this, right? And so it's sort of this idea of chaining these through. So what we see is we see tags as the first argument to this filter, and then we have an inline function that's generated. It calls vim9 ternary, which is just a function that we've written inside of vim9jit that, because we don't actually have ternaries inside of Lua in the same way, we can simulate that with inline functions, or if there's no side effects we can guarantee, then we just immediately can put the result here. And then after filtering this, we then filter the outer one, which we have to do some additional operations because vim9 script and Lua have different ways of determining which things are true. And so to compare things with OR, we actually have to use basically a wrapper around OR. But regardless of that, you can see that we're still doing that not static and not has key static. And we can see that it's comparing these two buff number results with the names here and filtering based on those two items. Ultimately, what we end up with is one big function here that has complete. This complete function is exported to the returning module, and at the end, that module is returned, and that module is then exposed with a corresponding generated Vim script function to create the exact same API as if this were still all written inside of Vim script. So some cool things for NeoVim about this is that even though we're not using vim9 script, we're still going to have, in general, much faster execution for some of these runtime files, because now all of the work, all of the difficult computations and everything like that, as much as possible as that has been moved into Lua, which is order of magnitudes faster than Vim script. If you want to hear more about any particular aspect of the generated code or how we did it or interesting problems or challenges, let me know. Leave a comment, leave a like, tweet at me, whatever. I'm happy to answer those or to look into more things. If you want to see exactly what the generated code looks like, check the link of this PR in the description, and you'll be able to look at all of the code because everything out here is open source. Everything's out in the open, and you can enjoy all of those things too.
I had a lot of fun making this. I had a lot of fun working on this. We did a lot of the work on stream, and it's been super exciting to see it move from something that I thought was mostly a joke that I didn't think would work to actually helping out the NeoVim community and still allowing Vim and NeoVim to coexist together. I hope you enjoyed this video. Hope you learned something new, and hopefully you got some new ideas, maybe even inspired you to try and do something that you didn't think was possible, but with a little bit of grit and a little bit of toughness and a little bit of maybe hubris, thinking that you would be able to do it. It might just happen. Thanks everybody, I'm THDV, and I hope you enjoyed this video. I'll see you in the next one. Oh, and don't forget to like and subscribe. If you want to sponsor me, you can do so on GitHub. Thanks everybody.